Hello everyone. So today let's solve the problem number 207 course schedule, right? So here, let's see what the question states here, man. Yep. So there are number of courses, nothing but num courses here. See, there are num courses labeled 0 to num courses minus 1. Labeled 0 to num courses minus 1. Yep. And prerequisite here, it consists of the prerequisite pairs here. One, so this one a comma b, nothing but here in the sense 1 comma 0 they have given, meaning we must take B before A, right? We must take B before A. See here, number of courses we have been given 2, and we have to take the course 0 before taking the course 1. They have said here, we must take course B before taking the course A. Yep. Again, we have to take the course 0 before taking the course 1. Yep. So this is the condition they have given. Yep. So we have to return true if we can take all the courses, right? So that is nothing but we shouldn't have any cyclic dependencies, right? If we have any other this one cyclic dependencies, actually if we cannot take the course before this one, then we have to return false. If we can take all the courses and if no cyclic dependencies exist, then we have to return true in that case, right? So yeah, this is the question actually. Yep, this is the question actually. See, let's come to the example one. This is one of the finest questions actually, one of the uh, good questions actually. This is fine. There are total of 2 courses to take. Yep, there are total of 2 courses to take here. So to take one, we should have finished course 0. So it is possible. We can take a course 0, then we can take course 1. In this case, it is possible. In this case, we have to return true. Yep. Now let's go with the second example. We have number of courses 2. Prerequisites we have 1 0 and 0 1, right? So there are two total this one of this one. What? There are total of 2 courses to take. This we know. To take one, we should have finished course 0. So to take one, we should have this one works fine. This is fine. This is fine. So to take one, we have to finish the 0 here. In this case, it miserably fails, right? We cannot, right? So to take 0, we cannot take 1. To take 1, we have to finish 0 here, right? So to take 1, we should have finished course 0. And to take course 0, you should have also finished course 1. So this is impossible. It forms the cyclic dependency here. So it is impossible. Yeah, in that case, we have to return the Boolean value false. In that case, we have to return the Boolean value false. They have given us wonderful examples, man, here, just for the sake of understanding. Yep. Now let's do one thing. Let's quickly discuss the this one. What do we call? Let's get into the approach part, man. So for the previous problem, we solved with the BFS, I think. So now let's for a change, let's solve this one with a DFS actually. Yeah, instead of the this one BFS, let's go with a DFS to solve this particular problem. Yeah, so let's go with a DFS here, right? So yep. Now let's discuss this. Let's discuss this step by step. We have let's consider the first example for the approach. Yeah. First, what we will do, we'll build the directed graph for the pair 1, comma 0. Right. So we'll build the directed graph for the 1, comma 0. See here, we have the prerequisites 1, comma 0 and number of courses we have here. So for this one directed graph, to finish one, we should have complete the 0 first course 0, right? So for that one, we can just write it in this way, the directed graph actually 0 to 1. Yep, 0 to 1. Yep. So to finish the course 1, we should complete the course 0, or we should have yeah, we should complete the course 0 actually. Yep. So we have successfully built the directed graph now. So 0 must be before 1 because to finish 1, we should complete the course 0. This is fine. Now what we will do accordingly with this graph, now what we will do, we will run the DFS with a node coloring actually. 0, this says actually unvisited. 0, this says unvisited. And 1, what does the 1 state here? Basically 0, so this is unvisited, and 1 is nothing but the visited. 1 is nothing but the visiting actually. Yep, in the recursion stack. What does 2 state here? 2 means already visited. So if we are giving 2 here, so this is for the 0 unvisited, this is for the 1 visited, and if we are giving 2 in the sense it is already visited in the sense we have completely processed actually. Yeah, it is completely processed actually. We have fully processed that one. Yep. So this is fine. Now this is the last step. So let's come to the last step here. So we have successfully this one. What do we call? we have successfully run the DFS. Now, so after running the DFS, let's start the DFS at node 0 accordingly with the example, right? So let's start the DFS at node 0. So we will mark the 0 as visiting actually. This one, let's mark this one initially as 1 as we are visiting this one. Yep. So now what we will do, we'll mark 0 as visiting, follow edge to the 1, follow edge to the 1. So this one actually. Yep. So this one. So we will mark 1 visiting as well. After 0, we will mark 1 as visiting as well. Yep. So visiting 1 has no outgoing edges. See here in the graph. So 1 has incoming edge, 0 has outgoing edge here from 0 to 1. This one directed graph, right? So 1 has no outgoing edge. It has only incoming edge, right? 1 has no outgoing edge here. So we will mark 1 visited and return. So we will mark this one as visited. Visited in the sense after this one, after this step visiting. So we will mark this one as 2. Yep. So we'll mark this one visited and then we will return. So back to the 0, right? So back to the 0. Now we will go to the 0. Now what we will do, we will mark this one as visited as well, nothing but 2. We'll mark this one as visited as well. Back to 0, we'll mark 0 visited, right? So no back edge to the visiting node found here, right? Meaning no cycle here, no cycle. So here in this case, we will return true as we don't have any cycle. Yeah. So in this case, we will be returning true. So the output that we got here is true, which is equivalent to the output that they have mentioned for the example 1 within the question, right? Example 1 within the question. So our approach works absolutely correct here. Our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah. So what will be the time complexity here? The time complexity would lead to big of V plus E. The time complexity would lead to big of V plus E, where V is nothing but the number of courses we know, nothing but vertex, edge is E, nothing but the prerequisites dot length of the prerequisites, right? E is nothing but the length of the prerequisites. Yep. So each node and edge processed once in the DFS. So overall time complexity we can consider big of V plus E. So what will be the space complexity here? Space complexity would lead to big of V plus E as well. So why it is big of V plus E here? So we will be going with the adjacency list and big of V for the color array as well. Overall, it is dominated by V plus E, right? So overall space complexity would lead to big of V plus E. The time complexity and the space complexity for the code that we'll be writing in the future would be big of V plus E and big of V plus E respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Let's start writing the code. Yeah. So the first step here would be this one. What do we call? Let's go with the adjacency list for the directed graph, right? Edge B to A for the pair A comma B. So I'll just go with the array list here. Let's go with the array list here. I'll just go with the integer, right? So let me mention the array. Let me consider the variable adj here. Nothing for the adjacency. So I'll just go with the new array list of let me pass the num courses here. Number of courses. This one. Num courses. So yeah, this is fine. So we have successfully went with the adjacency list for the directed graph, nothing but edge B to A for the pair A comma B, right? Now let's initialize the adjacency lists actually. Let's move on with the iteration, yeah, in simple terms. So I'll just go with for here and I equals 0, I less than num courses here, I plus number of courses, I plus. So this is fine. So let's create the list for the node I. So I'll just go with the adjacency of I and let me assign this one to new array list. So this is fine. Yep. So let me come out of this one entirely. Now let's do one thing. Let's fill the adjacency list using the prerequisites, right? So I'll just go with the for loop here. So this one int p, let me go with the p of the prerequisites actually, individual p of the prerequisites, right? So within the for loop, let's do one thing. Let's go with a course that depends on B and then the prerequisite course. And then let's add the directed edge B to the A. Let's do these three things. Yeah. So first one A equals P of 0. Then and B equals v of 1. This is fine. Finally, let's add the directed b to the a. So this one will be adjacency of b. So this is fine. Dot add of a. Dot add of a. This is fine. So let me come out of this one entirely. Next step, what we have to do, let's go or let's go with a color array just to mark node state during the DFS. Just to mark the node state during the DFS, right? So let's do one thing here. Yeah, let's continue with the same. We have to write the helper method, I believe. So here, so we have to check whether the graph has the this one cyclic this one cycle or not, or cyclic dependency or not, right? So for that one, we have to write the helper method. Let's see. First, let's go with a color array here to mark node state during the DFS. So I'll just give here int color equals new int of. So let me go with a number of courses, nothing but num courses. So let me copy this one and paste it over here, right? So let's try the DFS from every node, meaning it handles the disconnected components here, right? So I'll just go with the for loop here. And I equals 0. This one I less than number of courses I plus, yeah. So within this for loop, again, so if unvisited, meaning here if color of I equals 0, if it is unvisited, then we have to check for the this one actually whether it is having the cycle or not. If the cycle is found, then it cannot finish all the courses, right? In that case, we have to return false. Else we have to return true. No cycles found, we have to return true. So to check for the cycles, let's write the this one. What do we call helper method actually? Yeah, let's write the helper method. Just give me a second here. So this is fine. Yeah, let's move on with the further thing. So I'll just go with the helper DFS that returns true if a cycle is found starting from the node u, right? So I'll just go with private here, boolean. So let's consider the name as cycle DFS, right? So let me go with here, you edge u in it, and then let's go with the array list of integer. So this is also fine. So let me give capital I. So this is also fine. Adjacency idj, and let me go with a one more parameter, nothing but color. Yep. So within this helper method, the first thing, let's mark you as the visiting actually, uh, visiting one visited already. This one, two actually, not visited 0, right? So I'll just go with visiting actually color of you. Let's set this one to initially 1. Next step, let's explore all the neighbors v of u. Let's move on with the for loop here. For int v of adjacency of u actually, adjacency of u. So this is fine. So within the for loop, let's do one thing. Let's go with a simple if condition here. Neighbor unvisited. If the neighbor is unvisited, then we have to recurse, right? In that case, so I'll just go with if color of v. If it is equivalent to the 0, then let's do one thing. I'll let's recurse, right? So I'll just go with if has cycle DFS here. This is fine. Let me pass v. So we are going with a recursive DFS here, right? So adjacency as well as the color. So we have made use of the iterative DFS, we have made use of the BFS, right? So now we are going with a recursive DFS here. Just note this one, right? So if you're following along with me, the problems, basically the graph problems, we have already solved certain problems with the DFS actually, iterative DFS and the BFS as well. Now we are going with a recursive DFS. So this is fine. V adjacency color. These are three things that we need to pass, right? So this is fine. If then we have to return true. If the cycle found in deeper recursion, then we have to return true here in this case. Yep. So else if, so I'll just go with else if here, color of v, if it is equivalent to the 1 actually, then what shall we do here? If the neighbor is visiting, then let's go with a back edge, nothing but cycle detected here. In this case, I'll just go with return true, or let me return true here, right? So this is fine, man. Yep. If the color of V is 2, meaning neighbor is already processed and it is safe, right? Meaning it is visited already. Yep. So we don't have to write anything, I believe here. So now after this, let's mark you as visited, nothing but fully processed. So I'll just go with the color of you. Let me set this one to the 2 value 2. And finally, if no cycle found from the U, in that case, we have to return false. Yep. So this is it for the helper method has cycle DFS. So let me copy this one entirely. Yep. Now within the main method, so we are checking here. We are going with the if condition, right? So yep. If the cycle is found, then we cannot finish all the courses basically. Let me write the color of I equals 0 and let me write one more if condition here. If has cycle DFS here. So let me pass I adjacency as well as the color. So this is also fine, man. So then let's do one thing. Let's return false. Let's return false. So this is fine. If the cycle is found, we cannot finish all the courses. Now let's do one thing. The final one here would be if no cycles, then all the courses can be finished. So in that case, we have to return true actually. Let me return true here. So this is it for the code. Let me format the code once and let me hit the run button. I hope this works for all the test cases, man. Let's see. This I has to be capital. Line number 3. Oh, the first one itself. Yeah. Okay. Let me hit the run button again. So yeah, the sample test cases are getting passed. So let me hit the submit button quickly. So yeah, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.